CAD Partner presents the Smap3D solution ScanToCAD. ScanToCAD allows effective work with point clouds from 3D scans in 3D CAD. The underlying laser scanning and laser scanners used for this purpose nowadays offer the following features: an all-around visibility of 360 degrees with vertical visibility of 300 degrees, unambiguity interval of 80 meters, a linear precision of 2 millimeters at a distance of 30 meters. The duration of a single scan is approximately 3 minutes. Together with the necessary setup time, a two-man team creates an average of around 60 scans per working day. A 3,000 square meter hall can thus be scanned in 2 to 3 working days. The process of ScanToCAD is simple. Using a 3D laser scanner, a building or an object is scanned. The resulting point clouds are loaded into Smap3D ScanToCAD. From there, selected geometries are reconstructed and exported to 3D CAD as feature-based geometries. The essential functions of Smap3D ScanToCAD are the analysis of 3D point clouds through effective reconstruction tools, the export of primitives from the point cloud into 3D CAD, the support of all common scanner formats and types like ASCII, Faro, Leica, Optech, Regal, Topcon, Trimble, Zoller, Frulich, and E57. Computation of photorealistic representations from the reflectance values of the laser scanner or from the color photographs. Fast and effective reconstruction of technological equipment designed for straight pipe runs, bends, valves, or branches. A free viewer. Different windows in the user interface of ScanToCAD display the available information of a scan project. In the upper left window, all available scans in the project are listed. Each scan can be viewed in 3 different styles. The planar view is the flattened 3D view of a scan. The pictorial display is thereby taken from the reflectance values of the laser scanner. In this view, the geometry selection for the CAD export needs to be made. The spherical view is the all-around vision, starting from the scanner head, and is also represented with the reflectance values of the laser scanner. The point cloud view shows only the measuring points contained in the point cloud. In the middle left window, the scanner positions of the referenced scans are displayed. To export geometries with ScanToCAD from a point cloud into Solid Edge, the required points have to be selected in the planar view. With various functions, the selection can be specifically reconstructed and exported. First, the scanner location together with the ground level should be transferred to Solid Edge. For that purpose, 3 points along the shadow of the scanner tripod should be selected. With the function Export Circle, a circle is automatically created on the ground level in Solid Edge. The origin of this file corresponds with the position of the scanner head. After that, the ceiling level should be transmitted by selecting and exporting a line. In the next step, the room boundary should be transferred. For this, the function Export Intersection of the Line Segments is available. For that purpose, 2 points per wall must be sequentially selected. In the point list, the height of all points must be set to the same value. Then the resulting geometry should be exported. In Solid Edge, the corresponding result will be visible. The floor and ceiling level as well as the room boundary will be available as sketches. Parallel planes for the floor should be generated with the native Solid Edge feature. After that, the room boundary should be generated as a surface. Next, further geometries from ScanToCAD should be exported. The door boundary to the second room should be exported as a polyline. The zoom function in the lower left window is very helpful for these types of selections. The main geometry of the pump should be exported as a cylinder. Select the base area as a rectangle. Next, the first pipeline should be reconstructed and exported contiguously with the pipe module. For this purpose, a new pipe run needs to be created. Then the first tube segment must be defined by selecting a start and end point. After that, the pipe detection must be done for this segment over the algorithm of the cylinder detection. The calculated values will be transferred into the pipe module. Next, the position for the faucet must be defined, followed by an elbow, and again a straight pipe segment. With this approach, the existing pipeline will be reconstructed step by step. If necessary, additional scans can be involved. For the export, the option Pipes should be used to get the pipeline into CAD as solid geometry. The results are visible in Solid Edge. Also, the second pipeline should be exported to Solid Edge. For this purpose, this pipeline has already been reconstructed in the pipe module and saved as an XML file. After loading the XML file, the content can be exported directly. Next, the room boundary of the second room should be transferred. For this purpose, again the function export intersection of line segments should be used. 2 points per wall must be sequentially selected. The height of all points must be set to the same value and then exported as intersection. Native Solid Edge features will again work great with these geometries. First, the room boundary should be created as a surface. Then the door should also be created as a surface. After that, the door surface should be trimmed from both room boundaries. In the next step, a steel beam should be reconstructed in the second room with the steel module. For this purpose, 2 points as the length of the beam must be selected. After that, 1 point for the height or the thickness of the beam. If this selection is complete, then the dialog of the steel module will be displayed. The previously selected area of the point cloud is extracted and will be displayed in this window. With the measuring function, the appropriate profile size can be filtered. From the list, the required profile can be selected. With additional options, the selected standard profile can be precisely fitted to the point cloud. With the button Export Geometry, the beam will be transferred to Solid Edge. As the last requirement, a cable tray should be reconstructed in Solid Edge. For this purpose, 4 appropriate points must be selected in the scan. For all these points, the height must be set to the same value. After that, the points will be exported as a closed polyline. In Solid Edge, the sketch should then be used as the profile that can be extruded to avoid interferences in the CAD for future designs. With ScanToCAD, you can reconstruct geometries from 3D scans in a very time and cost-efficient manner. Contact us. We are happy to support you in your improvement process.